Good morning, everyone, and welcome to this lecture. This is lecture number 14, work, power, and energy, and we were dealing with motion in horizontal circle. In the last class, we had seen how we can make equations in different cases of horizontal circle. We have to make equations in three directions: one towards the center, one in the tangential direction, and one in the perpendicular direction. Do we all remember this? Do we all understand this? Yes or no? No doubts on this? Pakka? Okay, let's see. Again, I am going to give you a question and I hope that you are able to solve this. Now again, whatever questions we have done till now, they are exactly similar. You just have to understand it and get the solution. So this is the next question. You can compare it with the previous questions and understand how this question goes about. So the question goes like this. A block of mass m is tied to the first question it was spring. Now it is spring of spring constant k. Natural length is L and the other end of the spring is fixed at point O. If the block moves in a circular path on a smooth horizontal surface with a constant angular velocity omega, you have to find out the tension in the string. What all things are given to you? K, omega, and m. And the natural length of the spring is L. I'll give you 2 minutes to get me the answer. Try everyone. So how are we supposed to do this? We have to draw the free body diagram. I think it is already there. Again, I will draw one. This is the free body diagram I have drawn. Now, I have to make three equations. The first equation is towards the center. Now, this is moving in a circular path. Who is providing it with the centripetal force? Who is providing the block with the centripetal force? Is there any force? Yes or no?
Spring force.
Spring force. Spring force is providing it with the centripetal force. Okay. Will the spring be extended here when it is rotating, or will the spring remain in the natural length, or will the spring be compressed? The spring has to provide force, so there must be any. When does spring provide force? When it is in natural state, or when it is not in its natural state? What will be the condition here? Will the spring remain in its natural state, or something will change?
Natural in state.
Spring will remain in its natural state. Then, my dear friends, no one is going to provide it with the centripetal force, and therefore it cannot rotate in the circle because there will be no centripetal force. So the spring has to extend. Here in this case, this is not a question of physics. This is common sense that the spring will extend. I hope you understand it. Let us say that the spring extends by a distance x, because that is the only way it can move in a circle. You can try it at home. Spring will extend by a distance x. When the spring extends by a distance x, it will apply a force F. How much is the spring force? Do you remember the formula of spring force?
half kx square.
Formula of spring force is K into X. So that is the spring force Kx. Half Kx square happens to be the energy beta. I would request you to please go back and have a look. So now we know the spring force is K into X, and that is towards the center, and that will give it the centripetal force. Can now anyone tell me what will be the equation of this block in along the center? Anyone knows how to make the equation? Anyone knows how to make the equation? No one knows it. Okay. So the force towards the center is K into X. That must be equal to m omega square into the radius of this circle. The radius of this circle now becomes L plus X. The radius of the circle now becomes L plus X. From here, I can find out the value of X. What is the value of X? The value of X will be m omega square L upon K minus m omega square. That is the value of X that we are going to get from here. But they did not ask us what is the extension in the spring. They had no business finding out the extension in the spring. They wanted to find out the force or tension in the spring. Can anyone tell me what is the force or tension in the spring? I have calculated the extension in the spring. Can anyone tell me what is the force or tension in the string? No one knows how to calculate the force or tension in the spring. Well done. Well, force or tension in the spring is K into X. So you just multiply it by K. That will be your answer. K m omega square L upon K minus m omega square. That is the answer that we were looking for, and we got it from the first equation only, the equation that we had written towards the center. There is no need to write other equation, but still, just because I want to write, I will write it so that one day you would be able to understand what I am doing. I don't think anyone has understood anything up till now. No one can make the equation. No one is giving me any answers. I don't know what is wrong. Anyways, the second equation that I had to make was along the tangent. Can anyone tell me what is the equation along tangent?
No, sir.
There is no force along the tangent, so I don't have to write any equation. Force is zero. But again, I can make one equation along the perpendicular direction. Can anyone tell me what is that equation? If there is any equation. In perpendicular direction, whatever happens, the net force has to be zero. Can anyone tell me what is the equation that you are going to get in the perpendicular direction for this block? This
N
block
equals
is
mg.
kept on a surface or a block. So if you draw the free body diagram of this block in the vertical direction, you will see that there is mg acting downwards and normal reaction acting upwards. So if you ask what is the equation in the vertical direction, it is simply equal to n is equal to mg. I did not need to make this equation, but I made this equation so that you understand how equations are made. I'll give you 2 minutes to note all these things down. Let me know once you are done. We move on to the next thing. I am trying to do all the possible cases of horizontal circular motion because I know any one of these cases are going to come in your exam, but it is very disheartening to see that no one is even trying to do it. I don't know what's wrong. Is there anything that I can do to make things better? Please let me know because I think that no one is able to understand what I'm doing here. So it's a very sad thing for me. Don't know what's wrong. I don't think you seem to understand what we are doing here. No one is giving me any answers, and whatever you're doing, I mean, if I ask you the spring force and you tell me the spring force is half kx square, that simply means that you are not studying enough at home. That is not a good thing. I hope things will change, and I sincerely hope that the things change. Otherwise, it will be too late for anything to change. This is a time that probably you can make some things to change, and please do it, because the way that I see you going, it's not a very good place that you are going to. Please pay attention on studies better. Okay. The next thing that we are going to do will be is known as a conical pendulum. Conical pendulum. Now this conical pendulum is the brother of simple pendulum. We'll also do simple pendulum probably in the next class tomorrow. This conical pendulum looks like this. Anyone have seen a conical pendulum? Or anyone knows what is a conical pendulum? No one, of course, knows it, because I don't know. You might not have heard about it. Whenever I ask anything, you obviously don't know. So this definitely you would not know. Anyone heard about conical pendulum? Yes, as expected, no one has heard about it. You may not have heard about it because you have not heard about simpler things. This is a typical thing. So I don't expect you to have known about this. This is how a conical pendulum looks like. There is a string. You attach a string to the ceiling. Then there is a bob at the end. The simple pendulum goes like this. This is your simple pendulum. I hope you have heard simple pendulum. Have you heard simple pendulum? Chalo. Simple pendulum is like this. Conical pendulum is like this. If I rotate it like this is your conical pendulum. It rotates like this on the horizontal plane. That is the conical pendulum. I'll give you 2 minutes. Note down the diagram first. So I guess anyone has drawn the diagram. Now we are doing this case once, and remember these results always. Now, in the question that comes, you might have different things given and different thing asked. Here we have written everything. Uh, this is L. L is the length of the pendulum. I hope you understand this. Theta is the angle that this pendulum makes with the vertical. R is the radius of the circle. M is the mass of the block which is attached to the pendulum. Now, once you understand this, you can remember simple things, and those simple things are going to make your every question in this particular case of conical pendulum very simple. For example, this R, the radius of the circle in which the conical pendulum moves, can be given by L sine theta. This is from the triangle, right angle triangle. You can see R, L, and theta are related like this. Do we understand this, everyone? Okay. Now, if I make the equation of this block, and what would be given to you is the velocity with which this block is moving. So let us say you understand this block is going to move with this velocity like this, SAS. And let us say the velocity is V. So this velocity V is also given, let us say. Velocity with which it moves is given, and remember this V will be constant. The speed with which it moves is constant. Okay, now I can make the equation. The first equation is towards the center. Can anyone tell me what will be the equation towards the center? This is T. T is going like this. So I will have to resolve T into two components. One component will be going towards the center and one component will be going in the vertical direction. This component will be T cos theta and this component will be T sin theta. So if I look at the equation towards the center would be T sin theta will give us the centripetal force mv square by r. I hope all of you understand this. The second equation that you can make is towards the tangent. There is no force acting towards the tangent. Speed is constant. Force is zero. I don't have to write any equation. The third equation is in the perpendicular direction. Can anyone tell me what is the equation in the perpendicular direction?
T cos theta equals to mg.
Great. T cos theta is equal to mg. Now, these are the equations that you can make. And by combining all these equations together, this one, if I combine these equations together, I can get relation between all of the quantities. I hope you can get those relations. Anyways, I hope you can get those relations. So now if I divide the two equations, I will get the third relation. I will get the relation tan theta is equal to v square by rg. All of these relations are very, very important because any relation can come in the examination hall. Tan theta is equal to v square by rg, or you can also write it in terms of v. The speed v will be rg tan theta. You can write the speed v as rg tan theta. Now, once you know the speed, you can also calculate angular velocity. How will you calculate angular velocity omega? Can anyone tell me? Does anyone remember omega? How will you get the angular velocity omega? No one knows it? Okay. That will be V by R. So if I calculate V by R, I can get this answer. Sorry, I did not write the root here. Root over Rg tan theta. So if I find out the angular velocity, I will get the angular velocity as root over g tan theta by r. Please note it down. All are important results. I know you will not remember them, but it is our duty to write it at least. If you don't remember it, it's your fault and you will have to face the consequence of that fault. That is the angular speed. The last thing is time period. Time period is 2 pi by omega. So I can write it as 2 pi root over r by g tan theta. Now also remember that this r is L sin theta. So if I just put that value, I will get this as L cos theta divided by g. And that is all the results of this put together. One more result you can find out. You can find out the value of t. How can you find out the value of t? T will be equal to, you square both the equations and you add them. So T will be equal to mv square by r, the whole square, plus mg. Hold the equations of all the things written together. I'll give you 2 minutes to note it down. Please let me know once you are done. Write the next heading, and the next heading is turning of vehicles on circular roads. So write the next heading, turning of vehicles on circular road. Turning of vehicles on circular road. What do we mean by this? Turning of vehicles on a circular road. Yes. I mean, it means what it actually means. You have a vehicle and you will have to turn it on a circular road. How are you going to turn vehicle on a circular road? Yes. If a vehicle has to turn, how will the vehicle turn on a road? What will make it to turn on a road? Any idea? How can you make a vehicle turn on a road? What helps us? What helps a vehicle turning on the road?
Friction.
Friction. Well done. By friction. By friction only. So what happens in this case? We are completely relying on friction to turn our vehicles. Now what I am going to draw is a top view of a car or a vehicle which is moving on a circular road. This is your car. The mass of the car is m, and it is trying to move on a circular road with a velocity v. The center is here and the radius is r. Now it is trying to turn on the circular road, and as the heading says, by friction only. So who is providing it with the centripetal force? Which force is providing this car or vehicle centripetal force? No one knows it. Okay, so it is going to turn by friction only. So friction would be providing it with the centripetal force. What type of friction will act between the wheels of the
Frictional force.
car and road? Yes.
Frictional force, sir.
Thank God that you gave the answer after I written it. Anyways, I hope you knew it.
Like
The
friction.
next, the next question comes. What type of frictional force? Static, kinetic? Kinetic friction, my dear friend, never helps.
Like friction.
It was to turn. It is static friction that helps it to turn. If the friction becomes kinetic, your car will never run on the road, better it will skid. And a skidding car only faces an accident, it never runs on road. Static friction is going to provide it with the frictional force. Now I will write the equation. What is the first equation? It is always driven towards the center. Can anyone tell me what is that equation? No one knows that equation. Well done. That equation is,
Square by R.
you are too late. Fs is
B square by R.
mv square by r. That is the equation along the center, towards the center. Remember, friction is static. We don't know the value. Number two, and I keep on doing this for all these questions so that you realize that everything is simple and everything is safe. There is no net force, so we end up with 0. Then I end up with the third equation, perpendicular. I have not drawn the diagram of the perpendicular thing, but this thing is on a road. The net force in the perpendicular direction has to be 0. What is the equation that you are going to get from there?
N equals to mg.
N will be equal to mg. These are the equations that you are going to get. Now, so far so good. Now, if I say that the coefficient of friction between the vehicle and the road is mu, the coefficient of friction between the vehicle and the road is mu. We don't know the value of static friction, but we know what is the maximum value of static friction. What is the maximum value of static friction? Static friction is always less than or equal to what?
FL, sir.
Limiting friction, and the value of limiting friction is fixed. That is equal to mu into n. So I am just going to put the value of Fs from here and the value of n from here. Can anyone tell me how does the equation look like then? mv square by r will be less than or equal to mu mt. M and m goes away. So I have this revolutionary equation. V square should be less than or equal to mu into g into r. It should always be less than a particular value. So I can have a maximum velocity, and this is the velocity that is the maximum velocity with which you can turn on a road using friction only. This is the maximum velocity with which you can turn on a road using friction only. V max is root over mu g into r. Oops, what has happened here? V max is mu into g into r ka root. Now, whatever happens if if it is raining outside, the value of mu will become less because of water between road and the tire. And therefore, if you are moving faster and you try to turn, the car will not be able to turn, the car will skid and badam. And that is why most of the accident badam happens on turn. Because if the car is fast, it will not be able to turn and badam. Well, accident can happen on straight road as well. The most likely spot is where we turn, and this is the maximum speed with which we can turn on a circular road using friction only. Do we understand this? You understand everything, but after 2 days, everyone forgets it. So that sort of an understanding is very bad for our health. You understand? And after 2 days, hey, chill. You understood that, enough. I'll give you 2 minutes to note it down. So now we come to the next case. And what would be the next case? The next case would be turning. Obviously, we are going to turn, but we are not going to use friction. Then what we are going to use? How can we turn if there is no friction? Obviously, it will become very difficult for us to turn, but still we can turn. How can we turn? The next way of turning is by banking only. What is this banking? This is not the banking that you know, where you go and take your money out. And what is this banking? Roads are banked. What do you mean by roads are banked? Anyone? Roads are banked. Banked like this or like this. At some angle theta, they are banked. You must have seen all those cycling races. If you would have seen, it happens in a space where the road is banked like this. If you see a F1 race, Formula 1 race, or a motography race, you will see whenever there is a turn, you will see that the road is like this, slanted. If the turn is on the left, the road will be like this. If the turn is on the right, the road would be like this. Have you noticed it, everyone? Roads are made at an angle on turns, especially whenever they are meant for high speed. Why they make it like this? They so why do they make roads like this at an angle? Why they have to make it at an angle? Because as soon as you make it at an angle, your car goes like this. This is your car. Now this car has to turn. This car has to turn, and if I now draw its a free body diagram, its mg remains here, but its normal reaction, which was previously coming vertical, now comes like this. Now what happens when its normal reaction goes like this? This normal reaction can now be broken up into two parts. This angle will turn out to be theta. So this component will turn out to be n cos theta, and this component will turn out to be n sin theta. Remember this. Now basically what is happening is this is trying to turn. This is trying to turn in a circle whose radius is given as r. Now it is trying to turn in a circle whose radius is given as r, the radius of the curved path. Now I can make these three equations. The first equation is towards the center. Can anyone tell me what will be the equation towards the center? And that equation has come because the road is gone like this. What equation will come here? No one knows it. Okay. N sin
N sin
theta
theta equals to mv square by r.
mv square by r. Well done. Then the second equation would be towards the tangent. There is no equation possible there, so I leave it. The third one is in the perpendicular direction. What is the equation in the perpendicular direction? N cos theta is equal to mg. These are the two equations that you get. Now you can divide equation number 1 and equation number 2, and you will get this legendary result. Tan theta, we have got this result previously also. Tan theta is equal to v square by rg. Tan theta is v square by rg. We have got this result previously also. Tan theta is v square by rg. Now you can write it in this way also. V square is equal to rg tan theta, or the maximum velocity possible will be rg tan theta. It depends on the tan theta, with what velocity you can turn on this road. And if you compare this formula with the previous formula, the only difference is in the previous formula it was root over mu rg. In this formula it is root over rg tan theta. So in place of tan theta, you have mu in the previous case. Do we understand this? I'll give you 2 minutes to note it down now. So here is the question for you. You need to solve it. Whatever you do, beta, just remember that most of the hard work that has to be done, we are doing it here now in the classroom. We are writing all those equations and getting to those shortcut formulae, so that in the examination hall you can just use those things and do your questions. If you don't remember things, then it becomes very tough for you to solve any question. Traffic moving at 60 kilometers per hour. If the radius of the curve is 0.1 kilometers, what is the correct angle of banking? How are you going to do this? Anyone? How are we going to do this one? No one knows it? To find out the angle of banking, my dear friends. How will you find out the angle of banking? Any formula we know?
And it is custom square by RJ.
Well done. You just find out tan theta V square by RG. Remember, everything has to be in SI units. So you have to convert this 60 kilometer per hour into meter per second. Do you remember how to do this?
Multiply this algorithm.
So it will, I think, come as 50 by 3 meter per second. Yes or no? And you have to convert this kilometer into meters and put it here. So your tan theta will be coming, I think, as 50 by 3 whole square divided by radius. Radius is coming as 100 meters. The value of G is given as 10. If I put these values, you will get 5 by 18, or theta is tan inverse 5 by 18, and that would be your angle of banking. Do we understand this, everyone? Yes or no? No, yes. Everyone understands this? Pakka?
Yes, sir.
Okay, quick, 1 minute, one more question, so that we understand this concept of turning of vehicles on road. Fatafat, give me the answer for this one. What is the answer for this one? Find the maximum speed at which a car can turn around a curve of 30-meter radius. So radius of the curve is 30 meters on a level road. So road is not like this, no banking, level road. If the coefficient of friction between the tires and the road is 0.4, the coefficient of friction between the tire and the road is 0.4, acceleration due to gravity is 10 meter per second square. Can I have your answers, please? You have to find out the maximum velocity. Can I have your answers, please? What is the maximum
Root over mu GR.
Vmax? Is root over mu gr. That is what you need to apply here. Put the values, get the answer, and stay happy. Under root of mu is 0.4 into 30 multiplied by 10. So I think you will get something around root over 120, which is approximately 111 meter per second. Square of 11 is 121. Do we understand this? Yes or no? This is how questions are made in this particular topic. In the next class, we are done with the horizontal circle, and I hope you have to remember it. And do not disappoint me, because we are not going to see it again unless we do revision in the next year. This is, my dear friends, motion in a horizontal circle. We will now start in the next class motion in a vertical circle and see what all things come there. Take care. Have a nice day, and I'll see you tomorrow. Please remember what we have done today. I request. Please, 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 please remember what we do. And please try some questions at home. Please. Sincere request. Take care, and may God bless you all. Bye bye.
Thank you, sir.